a quick introduction about what is Dev Day. So Dev Day is a community-based event which is organized by the Sahaj. Basically, the developers, engineers, or the technology lovers, they come here and they share their ideas or the problems which they solved or something unique or innovative which they have to showcase. So we have hosted multiple Dev Days in the past, which covers the wide range of the topics, and all can be found on the YouTube. If you have anything interesting to say, share, or the any problem which you have solved, or something unique perspective about any technology or something you have, please feel free to reach out us, and we will be happy to welcome you as part of our next Dev Day program. So talking about the today's talk on the Dev Day, which is the AI agent from concept to code with the LangGraph. So today's speaker is the Sibin Bhaskaran. He is a solution consultant and the technology lover at the Sahaj AI software. Basically, he has the experience of 10 years, a decade, and he worked on the extensive technologies like the this RPA, which is the robotic process automation, and the ML, and the spanning backend development. So in the today's session, he will be covering with the real life use case, like what is AI agent and how you can use it to solve the complex problem, and how to build the multi-agent system using the LangGraph. And beyond this, we will at last we will see how to integrate with the databases and the REST APIs. So please welcome Sibin Bhaskaran. Thank you.
Hey, thanks a lot. Oh, just give me a minute. Okay, hope I'm audible. If there's any problem in terms of my voice, my audio, or in terms of what you see on the screen, please highlight, please raise your hand, let me know. Before I start, just want to give a bit of credit. So I am the one who is presenting this today, right now. But at least from the PPT standpoint, there was one more guy from our company who's Sachin from our Bangalore office. He had helped us. So just wanted to mention that. Okay, so let's start. Let's start with a bit of a nostalgic side of everyone from here. So most of you, I believe, would have had an experience where you and your team put in a lot of efforts, maybe for a week, for a month, had an amazing development lifecycle, did everything perfectly, or what you could do. You did your testing as much as you could do. You put everything on production. And again, even after going to production, you made sure everything is working perfectly fine. So you did that. You did all of those things. You went home. Everything was good. But maybe between, let's say, midnight or maybe the next day, you saw a lot of things have gone wrong. You wanted X to happen, but a lot of things have gone wrong. Things are broken. Production is down. Users are impacted. Not just users. Revenue has been lost. So now, what do we usually do? We end up, okay, we bring in the whole team. Maybe there's a war room that's set up. We end up trying to see, okay, what's the issue? What the issue is, debug things, fix things. This might take a few hours. I don't know. Maybe a few days, depending on the issues. And then that's how we do things, right? But what if we didn't have to do all of those things? Or if there was an alternative, let's say. Let's say we did the initial parts exactly the same. Nothing changes. You deployed everything. But instead of you figuring out, okay, something broke and you had to fix those, let's say there was someone who was proactively monitoring everything. And as soon as an issue happened, it took some actions. For example, first of all, identifying an issue happened, that itself is a critical thing. Secondly, once an action has been identified, taking some actions. So simple things, what we can start off with is, let's say, the system automatically got rolled back, for example. That's also a huge thing, right? Because now we are allowing systems like the users to not have an impact with the new release. You simply roll back. That's fine. Although you roll back, the systems are not impacted, the revenue is still there. Secondly, once you figure out, okay, what the issue is, now Second option is what the fix is, figuring out what the fix is. And once you have the fix, what you know what you have to fix, you actually make the fix. Okay, so three things. Now, let's say someone proactively, in this case, definitely what we are talking about is AI agents, where AI agents can themselves monitor everything. Once it sees, okay, there's a critical issue on the in the system on production, it simply executes some rollback scripts. Maybe you yourself have already created a rollback scripts because I think that's more reliable. But you allow an AI agent to do that, execute the rollback scripts and go back. And maybe even it can also suggest you the fixes. Maybe let's not go beyond, let's not say that it will also fix it for you. Maybe that's a step too much, maybe right now, maybe today. But let's say at least it will suggest those solutions. So the problems where you had to figure out what the issue is and then actually fix it, the time that it takes, that's reduced a lot. The impact that the users had, that's gone. So that's how we want to look at this problem statement and how AI agents will help you. Okay. What today we will do is majorly look at few concepts on a very high level. Majority of the talk would be actually practical. We'll look at an implementation. Not exactly this one. It would be a much more simpler use case that everyone can understand. And we will see how it goes. Okay. Okay. I'll give you one more example so that we can think more concrete. So everyone has heard about LLMs, right? We know what LLMs can do. We all have interacted with LLMs, or the majority of everyone. What do? We just go to, let's say, a portal or let's say an API, whatever the interface is. You give some prompts, you set up the context, and you ask maybe a question or give it a task. So that's what an LLM can do, or how you interact with an LLM. So let's say the use case is a meal planner, okay? And you ask the LLM, okay, I want to get a meal, maybe a recipe or whatever for your specific needs, and you give the context and you generate the meal plan. Now, what's the problem with this? It does not know much about you. Whatever context you gave maybe in the prompt, in the input prompt, that's what it knows, nothing beyond that. What it has is actually the training data that it had. So its responses are majorly based on that training data and not basis your preferences. So, and whatever output you get, maybe that's not even relevant to what you wanted. So definitely you can add things in the prompt, you make that response better. But again, it's limited. It's again with respect to you. Now let's go back to if this was like a system requirement. Maybe it's a system with thousands or lakhs of users and everyone wants a meal plan. Now, no one is going to do like create a prompt for themselves, right? They are just going to say, hey, these are my preferences, give me meal plans. So it's like what we can do is instead of just asking LLM a direct question, we can actually build some compound AI systems and not just a prompt-based system. What we are saying is we have a query, which is in this case, we are saying generate a meal plan. But we say we add an additional step, which is for that particular user, we get the preferences maybe from a database, because when we say it's application, we might have data for all the users, starting from what diet preferences are. Maybe they are following a specific diet, and whatever information, maybe their age, what they like, what they don't like, the ingredients. So you fetch data for that user at that point in time, and you feed that in the prompt, maybe to the LLM, and you get a relevant answer to that user. It's not limited to a prompt that you make at that time, but it's dynamic across your system. So this is what we are talking on a high level, what a compound AI system is. And you might have heard the term RAG a lot. So when we talk about RAG, so the flow that we mentioned here, it's very similar. So what we are saying is we have a query, we hit a data source, we fetch relevant data, we give the information to an LLM, and we get the answer. Okay. Now, anyone here who does not know what a RAG is, I can give a very basic intuition. like very general level, that would help understand things. Again, I just want to understand the audience a bit so that I can change things a bit. Anyone who wants more info on RAG, feel free to ask. Don't worry. Anyone? Okay, then I'm assuming everyone is good with RAG. Okay. So what does it help in this case? We are saying we can dynamically adapt the responses based on who is asking the question, even though the question is exactly the same. But it's not that we are saying that, hey, that's the solution for everything. It has its own problems. It is not realistic, I would say, from everything that we want to achieve in a real world. What this RAG or this particular solution, it is just in case of you want to retrieve some information. That's it. What if you want to do an action, like the example that I gave previously? It has to roll back something, right? It's an action. It's not retrieval. You have to maybe fix the problem itself. It's an action. So that's not going to be enabled by this solution. In addition, now this is like a fixed flow, right? You're going from query to searching and generate. These are like fixed steps or fixed sequence of steps. How do you dynamically change the flow? Let's say if there's much more in the business, it's not this straightforward. Definitely, you can add your if-else conditions. If like that's the traditional way of doing it, right? You write your program, you write your if-else conditions. That's one way to solve that problem. But definitely, the action thing is not solved. But maybe the flow thing you can solve programmatically. But can we take a step further and make it better? So this is what I was talking about. The programmatic flow where you define, okay, hey, if X happens, then do Y. If Z happens, do A. I don't know. So you just write the conditions. And I would say, or at least right now, I would say that's a very good way to do because you already know what the scenarios are. And you can directly go and execute those things. The thinking part of things are very limited. It can be done very quickly. But let's think from an agent's perspective. What we do in this case is we don't write those if-else conditions. We don't say, hey, if this happens, then do this. We don't do that. We just say, you can do this, you can do X, you can do Y, you can do Z. We don't say when to do it. Okay, you just say you can do it. That is, you're defining the capability. You're saying you can do all of these things. But when to do it, in what sequence to do it, that control is completely given to agents. So that's how we are saying that we remove the overall programmatic piece, wherein the program itself has to take the decision. Here we are saying it changes dynamically basis the problem that we have in hand. So it's more of a dynamic system. And in addition, these things that we said, it definitely involves actions. And definitely we'll see examples even through implementations. Okay, so this is not a complete definition of AI agents. It's no way perfect, but just to understand. So it says an AI agent is a software that can interact with its environment, collect data, and use the data to perform self-determined tasks to meet predetermined goals. So here we are saying the humans set the goals, but an AI agent independently chooses the best action it needs to perform to achieve those goals. So the things that are marked in bold, you can see we make aware of what the environment is to the agent. We let it know, okay, these are the set of tasks, but it determines itself, okay, what it can do at a point in time or what it needs to do, basis the goals that have been set. So this is what we do when we build an AI agentic or an agentic application. We set the goals that the application should achieve. We give some capability to those agents so that it can actually execute a task. And definitely those tasks would be aligned to the goals. And all of these things are definitely augmented and changed basis the environment or the context. Sorry, because from user, as the user changes, the environment changes, the context changes. So that's how we will define an agentic application. We don't define the complete flow. We just define the goals, we just define the capability, and then it does everything for you. Let's take one high-level example. Again, this is not the only way it can happen. This is one of the ways. So what happens? We get a user query, and once the user query is with the LLM or the AI agentic application, it has to think on that task. So earlier in the traditional flow, we already have defined, okay, if this is the user question or this is a task, there is a if-else condition, let's say, and it is executed. However, in this case, this is the major difference where we say you have not defined that flow. Rather, the LLM first thinks, hey, this is a task. Now, what can I do? It looks at the environment, it looks at the task or the tools or let's say the capability that it has, and it determines what it can do. Once it determines, then it actually acts on those things, whatever it decided in the earlier step. And to act on those things, we have something known as tools. Again, we'll go into details what tools are. It executes those tools to complete that particular task. And once the execution is done, definitely after execution, you get some output, right? It observes those things because maybe the output of the task was relevant, maybe it was not, maybe it did something it did not expect it to. So based on the observation, it will deviate or change its flow so that it can still answer the final or do the final task. So it will take dynamic decisions based on observations. This can go in a loop. It can go into n number of iterations, and finally you get an answer. Okay. Again, this is one of the flows. As I said, there are a lot of other ways. Now, when we talk about agentic applications, there are a specific set of components that are required. So you can see the agent is at the center. It has all these things so that it can do the job well. Let's start from the right. So we said we get a question. The first thing that it does is planning or thinking. To do planning, there are a lot of strategies out there. Some are listed here, like reflection, self-critics, chain of thought. Again, you can actually go and read about these different strategies to think, because when you instruct an LLM to think, if you give some structure to that process, it does the job way well. If you just say, hey, this is the question and think how to solve it. Because if you give it a structure, it actually follows that structure and does thinking process very well. So defining a structure is good. And these are the strategies to do it. And again, there are a lot more in terms of strategies. We'll go through even an example, a few of them. Once the thinking is done, we said an action would be taken, right? But to take an action, we said we will give a set of tools. Now, let's go into what tools are. We have given some examples, like we have a calendar tool, we have a calculator tool, and it can be anything, literally anything. It can be anything. It depends on what you want to achieve in that application. Okay. And let's say if your task is a simple addition, simple multiplication, or whatever, maybe that application can have a tool, something like a calculator. So if someone gives a question or asks a query, hey, what is 2 plus 2? It will identify, okay, out of all these tools, the calculator makes the most sense. It will actually call that tool after the thinking or the planning stage, because it will identify that's the most relevant tool, and then that tool will be called. So as I said, tools can be anything. It completely depends on you what capability you want to give to the application or to the agent. Again, we'll go into specifics later. And to finally, on the top, you can see there's a memory component where it says there's short-term memory, there's long-term memory. Now, to give some examples, let's say you are having a conversation with, let's say, a bot or with a LLM. Short-term memory, you can imagine something like in a particular conversation, what all things you already have said. So that, let's say, if you ask a follow-up question, it still needs to refer to those things in the past, if it's linked. So those are things that you can think of like a short-term memory. But it might happen that the system has been used by the user for a very long time, right? Maybe months, maybe years. And there are some specific preferences that have been identified or even set by the user. So those are long-term memories. where you will fetch in those kind of preferences or identified patterns and then feed in to the agent so that those things are also considered while responding back. Okay, so these are in terms of memory. Now let's again jump into an example to look at one of the flows. This actually is not a very straightforward flow, it's a complex flow. So you can see the task is, I think you might understand, it's simply a document authoring kind of application where you give a topic and it will actually get you a document created with all the content that you want. Okay, so all the user does is gives the question, hey, I want to create a document on X topic. We are saying there is an agent who is a supervisor. The supervisor agent simply looks, so in this complete system, there are multiple number of agents. So you can see a supervisor agent, a research team, which has multiple agents. So the supervisor is just routing the request to different agents depending on the task at that point that it needs to do. So for example, someone asked, hey, create a document on topic X. The supervisor see, do I have any content on this? No. It actually goes to a research team, which again is already defined. That's kind of a capability that you have defined or a tool that you have defined. You say, okay, in the research team, now the research team agent itself questions or plans and asks, hey, do I have any content? It says no. Okay, now I'll have to first search where can I get relevant content. So it's like maybe it does a search on the internet. It finds relevant websites. Once that is fetched, there's another component who actually scrapes the data out of those websites. When this is done, the research team agent understands, okay, hey, I've done my job, all good. I'll return back. It returns the complete answer to the supervisor. The supervisor says, okay, now I have the content. Now what can I do next? It then goes to the document authoring team or the agent, where it has again sub nodes. You say there's a writer, there's a note taker, there's a chart generator. Maybe in the document you want to generate some charts, for example. So this is, as you can see, we have defined capabilities. We have defined tools for all those things, but the flow that it takes, it's completely dynamic. And it decides at that point in time and with the information that it has at that point in time. Okay, any questions here in terms of this example? Again, we'll go into implementation, we'll get into more details. Okay, so just taking a step back before looking at the implementation, we will on a high level see how things happen when we talk about a agentic application. Now, there are a lot of levels when you talk about an agentic application. Starting from the very first one, it's not even an agentic application, it's a simple traditional application that we have always built where everything is driven through code. Deterministic things, perfect. It works great. Now we are changing one thing. We are saying that decide. So you can see there are three categories, right? We say decide output of a step. So what if given a task, what is output of that? That's what we're talking about. Second is decide which steps to take, because there can be a number of things that can be done. We are saying which all things can be done. The last one is decide what steps are available to take. That's a lot advanced. What we are saying is we are not even giving you the capability now. We are saying, okay, this is a task, build the capability on your own, then execute it. So that's way more advanced what we are talking. So when we are talking about a very simple application, we are saying the first thing is only done by an LLM, which is deciding what the output of a step is. For example, let's go to the earlier example where we said we want to plan a meal. So we are saying this is the ingredients that I like. This is the diet that I prefer. Give me a meal plan. That's like a single task and an output. Okay, so we just gave that to LLM. Now, if there were any other things, for example, like basis this meal plan, maybe I actually want to create a detailed recipe. That's a next step that I want to take. But that is not done by LLM. It's a programmatic thing they're saying. So that's the most simplest thing that you can do. The third one that we see, the chain, that's where we are saying we are making multiple LLM calls. It's not a single LLM call. We are saying the first step is maybe create the meal plan. This is the meal plan, create the recipe, and then do something else after that. So we are creating kind of a chain. So the meal plan was created by LLM. The recipe was also created by LLM. So we create a chain, but it's a deterministic, again, it's a specific fixed chain. There's no dynamic parts to it. It will always flow, in this pattern. That's what we say, multiple step. Again, what to take, like what steps to take, we said it's a specific flow. So it's a programmatic thing. Let's take things a bit forward. We are saying a router. Now what happens here? Again, the output is taken, like the specific task output is done by LLM. Which steps to take next? Now that's the dynamic part of it. Now we are again coming to the previous thing that we talked about, where now it not just decides what the output of this task is, basis the output of this task, it also decides what to do next. So there's a lot more dynamic actions being taken. So this is the next level or a bit more advanced kind of application in terms of LLM. And when we talk about a state machine, there's a difference that you can see. Here we have said no cycles, here we have said cycles. The only difference is in the router, it just says, hey, take this action. Like it has, let's say, access to multiple capabilities. It has one capability which creates a meal plan, one capability which creates a recipe. Given a task, it just does one. So it routes the request dynamically, but it just does one. That's it. It cannot observe things and go back and make things dynamic. Whereas when we see cycles, it can actually observe things, make things dynamic, go back, maybe use a third capability and execute something else. So we are literally going in a loop and doing things basis what results we have. Whereas in the upper one, it just chooses a task or a capability dynamically, but it just does that, and that's it. And when we talk about the last one, that's, as I said, the third thing, that's the most difficult thing, because that is where we are saying we don't even give you the capability. This is the task at hand, figure out what the capability is, build that capability, and then execute it. That's way more advanced. It's kind of an autonomous system where LLM does everything for you. You don't literally have to do anything. So these are some levels that you can go through. And again, when we talk about the current maturity of the system in terms of LLMs and agentic applications and many other things, this is where we are. So we had earlier like the simple Q&A kind of system where you ask a question, you get back the response. That's it. That's the end of thing. We have chatbots. We actually can converse. Now it's not just a single Q&A. You can literally have a conversation you can ask follow-up questions. So that's the second level of an LLM application. We talked about RAG, where it gives you a bit more capability, where you can fill in some information dynamically because you retrieve some things from somewhere, and you get a more refined answer based on the context that you gave. We are talking about agents definitely in this talk. So that's where we'll majorly focus on. When we talk about an LLM OS, that's way more advanced. Again, it's not a reality right now. It's primarily conceptual. What they wanted to achieve is, if you right now, what do we have? We have like a CPU in our system, and that's the processing part of it, right? The main part of it. And it has a lot of capabilities built around it. Rather, the idea is LLM takes control of the system, that's the central processing, and it completely takes decisions on what the user wants. So it changes a lot of things. It's not just changes how it's processed, even how you interact with the system, that changes, because now you literally do things very systematically and planned, like you plan things. Now here you just define a task, maybe system does everything for you. That's something an LLM OS, but again, this is completely conceptual. And AGI, that's again artificial general intelligence, where LLM again can do everything for you. Just define task and hey, you have the answer then and there. But again, definitely the top two we have not achieved. Finally, let's go into specifics. Let's look at a working piece of code and see how agents can be implemented and how they work. Okay. Okay. Before going to this, let me first define what the use case is, what we are going to look at, and what we are going to implement. So I think at least in India, everyone relates to one topic for sure. Maybe not everyone sees it, but everyone knows at least something about it. It's cricket. Everyone knows what cricket is. So we are focusing an application on that. We have some data sources which have data related to cricket, specifically some data related to IPL, some historical information of IPL matches. And there is a different set of data where we are talking about future tournaments that are going to happen. Okay, some tournaments that are actually going to happen in the future. And we are going to see how we can maybe query the system, get some information out of it, and maybe do some actions as well, not just query. We'll also do some actions. Okay, again, we'll see what those are. Now, when we talk about these data that we have in terms of cricket, right? We have two data sources. One is an SQL database. SQL database has all the data related to IPL. Okay, and when we talk about the future matches or tournaments that are going to happen, those are being fetched from an API. So it's a REST API endpoint. So we are going to allow our agentic application to actually talk with these data sources, integrate with these, and do something for you. Sorry. Okay. So let's actually do one thing. Let's directly jump into the main part. Let's not even look at the code. Just give me a minute. Is this visible? Do I need to zoom in? Okay, so again, a simple question. We are asking, hey, get me all the latest matches that are going to happen. And okay, I think that's a bit the top. So we have our application running here. It has done something. Okay, it's doing something. Let's not worry about that right now. It did something. It generated some response, and it says, hey, the latest cricket matches are something something. There's an England tour of Ireland, South Africa. Again, all of these are 2025, June 11 to June 2025. So these are all future matches that are going to happen. And as I said, to fetch the future data, we are actually using some API. So actually, in this case, what happened is you just gave a natural language-based question. It figured out, okay, the data is with an API. It went to an API, made an API call, fetched the data, formatted it in a user-friendly manner, and gave you the response. Okay, that's what the final thing that you see. Now let's understand things a bit. What it did. Yeah. Okay. Okay. So let's first look at the flow that it took, and then we'll go into implementation. You see, it got a question. It triggered a simple agent in this case. Again, we'll go into details later. It says it identify a tool. And as we said before, tool is a capability that you gave to the application or to the LLM for basis what you want to achieve in this application. So we had defined a tool whose name was Get Cricket API. Again, you can definitely give more appropriate names, but this is a tool that the LLM identified given the user question. Again, how did it identify that? We'll go into details later. Basis that, it executed an API. So this was the API endpoint. It's an open source API that we have. It got a response back. Again, you can see the response is a huge one. It is a JSON response. It took in that JSON response, processed it something so that the response can now be represented in a more user-friendly manner. Okay, so this is the overall flow that it took. Now let's actually go into the implementation. So you can see this is the flow, or on a high level, this is what our application is. We have a starting node where the user gives you the user question. It goes to an agent. In this case, it's a simple agent. Again, you can get by the name. It's a very small, simple thing that it does. It's a simple agent. It came here. It did something internally. Okay, we are not going to details right now. As soon as it did that, in this case, it executed an API. the response is given to a generate final response component, which actually formatted it for you. And that's the end of it. So this is a high-level flow. Now, if I open this black box, which is a simple agent, let's see what happens there. Yeah, so we have our agents defined here. So let me go to modules. We have simple agent. Okay, so if you remember, let me go back to the slides so that I can give some context. So this is where we said we have an agent. We give all of these things to it so that it can do something. So we are saying we will give some capability, which is some tools to it. So we actually have defined a set of tools here where we said, hey, go and fetch the tools that you have. In the system, we have defined just two tools. One is generate and execute a query, which is interacting with our database. There is a second tool, which is get cricket API, which is interacting with an API. So that's the capability of this agent. Once the tools are there, we have defined LLM. Right now, we are using OpenAI API, which is GPT-4o mini. And once we have the LLM, we invoke that LLM. And to this LLM, what we do is we give the tools to it. So whatever tools we define, we give those tools to the LLM. Now, when we say we give these tools to the LLM, what is that exactly? We would need to know that, right? So let's open one of the tools. Let's open the API tool itself. You can see the tool actually it's like literally a single line of code, nothing beyond that. So the most important part when we say a tool, the most important parts actually are two things. One, the name of the tool. Secondly, the description of the tool. This is actually not important. Okay. Because basis the description and the name, the LLM then decides which are the most appropriate ones. Because, for example, what did you ask the LLM? Or what did you ask? We asked get all the latest matches. It somehow figured out that given these two tools, which were the database one, which is generate and execute query and get cricket API, it somehow figured out, okay, this one is a relevant one. That is what I need to call. But how did it decide it? That is basis this description and this name. If this was not up to the mark, if this is not defined well, it won't work well. Okay, so this is the most critical part of it. So what happens is when you say you are giving the tools to the LLM, what you're really doing is we are simply passing this tool description to the LLM. Now, if you want to look at it, we have integrated something which is known as LangSmith, where you can monitor everything that your application does. So in this case, we asked a question, right? Get all latest matches. So this is the trace, or this is the flow that your application took. This is where we said that we'll pass the tools, right? So you gave the tools and its detail. You gave the question, and basis this, it actually generated, or it said, hey, get cricket API is what you have to call. And what is the parameter? So if you had noticed, it actually took a parameter, and that's a user question. So it also created that, or it said in the parameter user question, you have to pass this value. It can happen that this tool can also take n number of parameters. It's not just one. So it will also define all those parameters one by one, and it will tell you what are the inputs that you need to give there. So it will extract information out of the user question and place it here. Okay. So once you have this kind of response, then it's your job. So you go back. Let's go back here. What do you say? Where is it? Yeah, you invoke the LLM. you gave the tools, you get a response, and that response is actually then processed, and you manually call those tools. Now, this is simply programmatic because you already know what tool to call, what the method is, what parameter you need to pass. Definitely, you can make that call, right? That's a programmatic thing. So you simply call that here manually. You simply invoke that tool. So in this case, this was a tool that it identified. You invoke that here. Yep. Yes, yes. Ideally, the tool name could have been more better for sure. But in this case, because the description, that is what we mentioned here, that was more relevant. So let's go through the description once. Correct, correct. Yes, yes. So let's read through it. Maybe that will clear things up. So it says, do not answer any questions other than the below mentioned topics. And what is the topic? We say current cricket matches and series. Okay. So anything that happens currently or after. No, if it's ambiguous, your performance or your accuracy will be also low. Yes. No. Again, if let's say you have defined two tools, so again we can let's do one thing. Yeah, let's do one thing. So let's come here. Let's say who is the president of India? Okay. Let's come here. Let's look at the logs. Okay. So the response, at least it said, I don't know. Let's look at the tool. So if you can see, it says the tools identified is none. Because the tools that you gave were relevant to cricket and the capability that it had was limited to that. But you asked a completely different thing. So it's not that it will always choose something. It's not that. It makes sure it's relevant to what you want to do. So going back to the description, yeah, I think this was a very simple thing. Like the tool is just simply making an API call. That's it. So we just had said, okay, it will give you data related to current cricket matches. And in the arguments, we defined it has one argument. And we said optimize smaller question in natural language to get the requested data. Okay, some information that it had in terms of that parameter. So although the name of this tool maybe was not that great at this point in time, but the description that was relevant, and that's why it figured out. There are limitations, but it varies from model to model. So for example, now what I'm showing is a tool calling capability of an LLM. First of all LLMs cannot or does not have this capability. Like given a question and a set of capabilities or tools, it can identify a tool. That capability is not with all the LLMs. There are mostly the bigger models, the OpenAIs, the Anthropic, and a lot more that has this capability. A very small model, maybe it does not have it. So right now, as I said, we are using of OpenAI 4 Mini. Okay, but again, there are a lot more models that has this capability, but you will have to choose a model which can do it because everyone cannot, or all of them cannot. Okay, so that's one. Any questions, or did I answer your question? Yeah.
So this capability of choosing a tool,
Yep.
when you say it is there in Open API,
Yep.
right? Open AI API.
Yes.
Is it specialized version of usual prompt which we use to get answers, or?
Okay, so usually, so in this case, actually, if you see, when I showed here, right? When I go to Langsmith, actually there is no prompt.
Okay.
There is zero prompt. Again, you can add a prompt. I'm not saying you cannot add a prompt, but for simple use cases, you don't even have to add a prompt because that capability is already defined with the model. As soon as it sees that, hey, it has given a set of tools and there's input, it knows, okay, I actually need to perform this activity, which is identify tool and give that as a response.
The description for the
So that is also sent here. Let me see. Yeah, you can see this, right? This is the description of this tool. Let me expand the other one. Get cricket APIs. This is exactly what we saw. Current cricket matches and series. Yep, I can. Yeah, your question, right? So the question was, how does it know, or what is the prompt that you send to the LLM so that it does a task, or this tool calling task? But as you said, at this point, it does not even need a prompt, because it, as soon as it saw that list of tools were given, it knows, okay, this is what I need to do, because it's predefined with that model. There are models which don't know this has to be done, so it cannot do. But again, you can change the behavior a bit. Maybe in that case, you can do, although the LLM does not have that capability, maybe you can allow it to do that by some prompting. So in that case, although the LLM does not have that capability, you are defining some things. You say, okay, now I'll give you some set of tools. This is a task. This is what you have to do. Maybe it will do it for you. So that's possible, definitely. And I think you had asked one question, whether there's a limitation in terms of description, right? So for example, OpenAI has defined a limitation, I believe, of 1024 tokens in terms of the length of the description of a tool. In the prompt, yes. Okay. But so are you talking from a limitation standpoint, or? Oh, yes. That's how LangChain is working right now. So we simply annotate this method as with a @tool decorator, so that we say, okay, this is a tool, and we have a description. So LangChain is doing this for you. It's like a simple thing. It simply looks at the doc that you have mentioned. Yes, LangChain picks up the description or the doc from that method or tool. It plugs that in the LLM call and sends it. So it's done by LangChain. That's the framework's work. Yes. So decision is basis this description. Now this is the. No, can you repeat that? Yep, exactly. So LangChain, what it does, it's making things easier for you in terms of how you program it. You have described this as a docstring for this method, right? LangChain, what it does, it picks up that description. It creates a prompt for you, like it appends all the descriptions of all the tools. In this case, there were 2 tools. It creates a prompt and it sends it to the LLM. That's where LangChain stops. Yes, because that's what we want to do, right? We want to dynamically decide or take a flow basis the user's question or task. Now, if you ask a different question, it will actually take a different flow. Okay, so let's maybe do that. Let's ask this question. Okay, so we said we have another data set, right? Which is related to IPL. Again, the data is not relevant, okay? In terms of the facts that we have in the database, that's not true. There are a lot of vague data there, like a batsman might not be a batsman or whatever. So ignore the facts part of it. But you can see it says, hey, the most expensive player in IPL history is Dhoni. Let's see how that was figured. So let's go down. Okay, you can see there's some SQL thing happening here. Let's ignore those things for now. Okay, so you can see again, the simple agent was triggered. The tool that it identified in this case was the other one that we had. Let's maybe look at the description of it. Yeah, the SQL tool. Let me zoom in. Okay, so it says answer user's question strictly regarding historical IPL matches, players and its results. There's something more that maybe we'll look at it later. But now you can see there's a clear distinction between tool 1 and tool 2. And basis the user's question, it dynamically decided, that is LLM decided which tool to call. So the decision that you said, it took basis these descriptions. And both these descriptions were passed to the LLM here. So this is a prompt that it created. Okay. So this is where we said, instead of writing if-else conditions, now we let the LLM decide the flow. But how does it decide it? Basis these descriptions. And now here, this is a bit more complex, okay? I think I did not actually give you or give some information here. Here we talked about all these things. We did not talk what is happening inside execute API. There's something, when we say execute API, it is actually not a programmatic thing here. There's an LLM involved here as well. So what we are doing is we have a document which is open API specification of a REST API. So we saw that we had a REST API, right? And there was an endpoint. We actually did not create the request of that API. We simply gave the question, that is the user's question. We gave this document through an LLM. This is the question, and this documentation actually created our API request dynamically. So you did not create the API request. The LLM created it for you. And once you have the request, obviously now you can make a programmatic API call, right? Because the request is the critical part of an API. As soon as you have the API request, you make that call. But creation of that API request was done by an LLM. Now, this document is simple. This just had one API in this case, but this actually can have n number of APIs in this. So what will happen is you get a user question, you have a number of APIs, it will figure out what was the most or what is the most relevant API that needs to be called to answer that question. So similar to how it decided the tool, it will also decide an API for you, and later it will also create a request for you for that specific API, which you can then trigger. So literally now you don't have to create APIs. So once you have like not the REST endpoint itself, you don't have to create flows where you will decide which API to call. You literally give a doc to it, it will do it for you. So that's way more dynamic. Yep.
How many we can attach to that?
Yes. So in terms of attaching tools, right, there's no limitation, but the more tools you attach, the accuracy would drop. So ideally, if you have, let's say, 10 to 15 tools, the tool selection and those things will work well in terms of accuracy. The more you attach, it would get confused more. So ideally, if you want to give a lot of capabilities, right, it is recommended to break the system down into multiple agents. Similar to one example that you saw in the PPT, right? Instead of having one single agent, in this case, we have a single agent, which has
search team.
perfect. So you have those different agents, which is looking at a specific task. And now that task can have a number of tools with, like to execute that task, it can have a number of tools. So instead of having everything at one place, you're breaking things down, making it modular. That would work way better than having it in one place.
Second is actually how we're converting text to SQL query.
Yeah, we'll come there. Okay. So this was actually text to API kind of thing, where you created the API request dynamically basis the API documentation. Okay.
And then is it limit to number of tokens we have?
Yeah, that depends on the model that you choose.
And if we have, okay, so for your scenario, this is actually API. So what if my documentation is way longer than the token size? Then
Correct. So then there also you can break down. So instead of having one tool with all the APIs, rather you can break down it to n number of tools, which has maybe access to specific APIs.
Like create a microservice out of it and then.
Yeah. So that's the engineering part of it, how you can do it. Okay. We were actually looking at the SQL before, but I wanted to show the API part of it because this is a bit simpler. If you look at the SQL part of it, right, that's a bit more complex. Let's see how that is being done. And as he rightly said, again, the LLM is doing that for you. You are not executing a specific query to answer a specific question. And this is the flow that we are executing for a SQL tool. N number of steps, as you can see. The first step is it is figuring out what the relevant tables are. Because when we talk about a database, it can have hundreds of tables, right? You cannot pass all the tables to a LLM because the context of an LLM is limited. The input that it can take is limited. So you first figure out what the relevant tables are. Okay. Once that is done, you figure out database schema for those set of tables. Because to create an SQL query out of a question, you need to give the schema to the LLM because the schema is different for all the database that you created. LLM does not know about it. So you fetch the schema. Once you have the schema, you give that to the LLM. Now it knows what the table is, what the structure is, what the data type is, and definitely what the user question is. Basis all this information, it actually creates an SQL query dynamically for you. You can actually execute that query then and there. It's fine, but a lot of cases happens where the SQL query might have some problems with it. So we have something here known as validate that SQL query. So you make or you perform some validations. Again, we'll see what those are. You fix that SQL query basis the validations, and we execute that query. Now, if let's say the execution is perfect, it ran perfectly fine, you get the results, you respond back to the user. But it can happen that because the SQL query is generated by an LLM, right? It can have some errors still. Maybe it's a syntax error, let's say. In this case, what we have done is we have added a loop wherein we execute the query, we get an error back. So what we do is we take the SQL query, we take the error, we give again that as an input to an LLM. So LLM sees the SQL query, LLM sees an error. So now it decides, okay, how can I fix this error given this SQL query? So dynamically, you are fixing your issue and you are recreating an SQL query which can execute end to end. Now this can go in a loop because it can happen that it fixed that particular error, but it introduced maybe a different error. So it can go into a loop. You can control this, how many times you want to go in a loop. But in most cases, it will work in maybe 1 or 2 iterations. And I'm saying this with experience. And once you have that fixed query, again, you can execute the query, you can have the results, you respond back.
So is this the observe part that you mentioned on the slide?
Yes, correct. So again, when you talk about observe thing, right, there's multiple parts to it. When we talk about the tool calling thing, right, that is also observe because you are giving the tool description to it. It is observing what those things are, what it can do with those tools, and it takes a decision what tool to call, like which tool to call. So that's also observation. Here the observation is a bit different, wherein you are saying, given the error, how do I fix the error? So definitely everything is observation, but you are defining what you need to do at that point in time. Let's go into a bit more detail. Okay, let's actually look at implementation of these things. Obviously, when we say there are LLMs involved, so there are prompts involved as well. Let me go into the SQL part of it. Let me open the get relevant tables node. To be frank, here we are not figuring out what the most relevant tables are. Okay, because in our database we have actually hardly any tables, like around 10 tables. LLM context is good enough to take in those tables. I do not want to complicate this, so we are actually giving all the tables schema to the LLM in this case. So although we are saying there is a node which figures out what the tables are or what the most relevant tables are, you can see we are literally fetching all the tables. But you can do n number of things here. For example, the usual thing that we do, or right now what's being done is we have the database schema. we have metadata for those tables. Like we literally write description for the tables, for the columns, and we store it somewhere. And when I say somewhere, we are storing it in a vector database. I'm not sure if everyone is aware of VectorDB. So again, I might not go into a lot of details. But what happens is, given a, let's say, a natural language question, it figures out using something known as similarity search. It figures out what the most relevant things are, and it returns you back. So that is something you can do here. Again, I don't want to go into details of those things because that's not what we are here for. But that is one way in which you can figure out what the most relevant tables are. Okay. Another option is definitely give everything to an LLM, ask it to filter down the tables and the columns. But again, that does not solve the problem, right? The problem was you cannot give everything to an LLM in the first place. So maybe that's not the right way. But again, as you can see, this is a programmatic thing. Nothing is, there is no LLM involved here. The second node was retrieving the database schema. Again, here there's no LLM involved. You got the table names, right? You're simply fetching the schema for those table names from the database. In this case, we are using a PostgreSDB. So again, this is a completely programmatic node. The next component, which was the most critical one, which is the generate SQL query. So this actually is where the most critical part is, which is generation of the SQL query, obviously, where there's an LLM involved. Here we are again using OpenAI, again, a GPT-4 mini. What we are doing is we are fetching the database schema, the table names, and the user question. We are invoking the LLM. So in the prompt part of it, we are dynamically replacing all these things. We are giving it the table schema, the table names, current date, maybe not relevant right now, the question part of it. There's something known as format instructions. I'll come back to later. Let's actually look at the prompt part of it. This might be a big prompt right now that you see, but you can see what we are doing is we are saying something like, "Hey, you are a Postgres kind of expert. You have some set of tables. Again, these are the dynamic part to it. You say this is the schema that you are looking at. You define some rules to it, because if you just say generate SQL query, it would do, definitely it will generate a SQL query because it is already trained on a lot of things, but it won't be what you want it to do. Maybe it will, let's say, for example, I'll give you an example. Okay, so see this one. I said never use a wildcard. Ideally, you don't want a wildcard, like you don't want to fetch all the columns in a database, right? So you're restricting how you want to create a SQL query. Let's see something else. Okay, when you say, let's say, when like operator is used, you are saying always use a percentage, because by default, it might not do that for you. So you are just defining some set of rules so that the SQL query that is generated is constrained around that. And finally, definitely, you give the question. Now in the prompt, not just you don't just give instruction in terms of how it needs to generate SQL query. You might also have to give it some business context, because SQL query is not definitely just technical, right? It might need some business context. So you also give some business information. For example, in this case, I've said, hey, always use player name column instead of whenever a player details are required. The reason I added this line was when it was not there, what it was doing was it was giving a player ID in the queries output. Now, player ID does not make sense to the user, right, in any way. So I grounded LLM saying that always use the player name. So this is something you'll have to experiment with, observe those things, and add to the instructions. Now, this is all it took to create a SQL query as the output. Now, if I go to the next one, which was the validation part of it, again, from a code perspective, right, you can see it's exactly the same. It takes in some inputs, there's some model there, you're invoking that model, and you're getting a response. So everything is same. The only thing that is changing is the prompt part of it. So let me open the validate prompt. you can see this prompt is actually quite small. You're saying this is the SQL query. So we actually gave the SQL query that was generated before. We gave the dialect because the queries should be relevant to Postgres, right? So we are saying the dialect is Postgres. And there is one instruction only here. What we have said, always use opening and closing parentheses for or conditions on the same column. So again, this was something that we observed when we created the application. What we saw was if there was a condition, maybe let's say a player name, and it let's say was like Rohit, because Rohit is like a very common name, right? To be frank, although there's one good player with Rohit, but there might be a number of players. If the query was something like player name like X or player name like Y or player name like Z, it's the or condition on the same column, right? Ideally, those should be inside a parenthesis because, again, this is a SQL specific thing we're talking about, okay? If there's, let's say there's one more condition which says and something else, if there is no parenthesis, the and is no more relevant, right? So the SQL query is completely wrong. So in this case, we observed that although the query is generated rightly, the parenthesis is missed by the LLM. So we said always add a parenthesis if this is something you are doing. Again, as I said, this is something you'll have to observe and then add. So this is kind of a double check kind of thing. So when we are saying validation, we are actually double checking the SQL query that had been generated in the previous step. And why are we doing this? Why did not we add this in the original prompt itself? We could have done that, right? But usually we observe that the more instruction that you give in one place, it tends to miss certain things. And it actually tends to make similar kind of mistakes. So given a particular LLM model, maybe in this case, Foro Mini, it tends to make mistakes like this one, like missing a parenthesis. Maybe if you have a different model, it might not make this mistake, but it might make a different mistake because it depends on how the training was done, right? So a particular LLM tends to make a similar kind of mistake every time. So this is a place where you can double check those similar mistakes that it makes and fix those. And obviously, once you have the SQL query, you can execute it. It's again a programmatic thing. There's no LLM involved here. So you are simply taking the SQL query and executing it here. And once you have the results, you know what we were doing earlier. So this one. So as soon as we said we get the results of an API or SQL, we simply give it to a generate file response component, which again it is an LLM call, which simply formats it for you. So in the prompt, we are saying, hey, this is the JSON you got, formatted in maybe a user-friendly manner. Again, you can have a number of instructions. Let's say you want to create a table out of it, for example. So you can give some instructions relevant to creating a table, how it has to be created. Maybe that will be done. It depends completely on you how you want to format your response. So we have a prompt for that. But again, that's not very critical here, right? Now, I think I had skipped one thing. Let me go back to one of the prompts. Let's say this one. So at the end, we had something like format instructions. Now, when you ask an LLM or you give a task to LLM and some context to it, for example, a database schema, you ask it to create a SQL query, right? It will give you a SQL query, definitely, but it might give you a lot more than just the SQL query. Maybe it will explain it to you like how it created or how it came up with the SQL query. It might say a lot more gibberish content that you don't even want to hear about or want to look at. Now, unless your response is a well-structured thing, you cannot process it, right? Because for a program to process something, it has to be well-structured. So you have to ground the LLM again in terms of the responses, how it needs to create a response. So what we do usually is, there is a framework known as Pydantic, which actually helps you with this. What you do is, so let me open the generate SQL query code. Here we are saying we have defined a model. So this is the query response model where we are saying we just want two things in the output. One is the SQL query itself, and second is a flag, a Boolean flag, whether a query was generated or not. Because it can happen, right? For whatever reason, the question landed up to this tool, which was a SQL generation tool. But this database does not have information to that question. Maybe the question was, what is the most, or what is the best player of the Brazil football team? But our database does not have that information. So the LLM will see that, okay, the schema is relevant to cricket, and it won't actually create the SQL query. So just to figure out if SQL query was generated or not, programmatically, we just have a flag here introduced, so that before even processing or execute an SQL query, you will first actually look at the flag, whether the SQL query was generated or not, and then if it was, we create SQL query. So we're grounding the LLM saying that just generate these two things in the output, nothing beyond that. So let's open the logs again. Okay, now this one, yeah. Okay, not, yeah, this one. So let's go down. Where is the generation part of it? Generate SQL query. Okay, did I not log that? So you can see this is the output. So it said SQL query is this, is generated is this. It actually did not generate anything beyond that. So this is very critical in terms of any component or any LLM call that you make. Always make sure you give it some structure to the response, because without any structure to the response, it will create literally anything for you. You cannot expect, or you can predict it. You cannot predict it. So definitely you cannot process that response. Now let's finally do a few things. Let me take one more question. I think, okay, I think I asked this earlier. Okay. So what is the answer to this? This said the most expensive player was MS Dhoni, right? But I know this is the wrong answer, because I know what the data is there in the database. If you look at the query that was generated, it says select player name from some table. And finally, okay, it said order by player price limit 1. Okay, but I know in our data, although data is not actually factually correct, I know there are players with the same price tag, which was the highest. So the LLM generated a query, but it put a limit 1 basis what? Basis this keyword, the most expensive player. So it assumed that it just required the first one. But our database actually had a lot more things. Now there are two ways to fix this. One, you go back to the prompt, you saw that this was a problem, right? So you will have to actually add an instruction in the prompt saying that figure out, don't just look at the first one. If there are n number of other results with the same value, which is the highest, incorporate that in the SQL query as well. That's one way to fix it. But obviously that's a change in the prompt. That's a more difficult way to solve. There's another way to solve this right now. What we did is we changed the user question in a bit, in a small manner. We said if there are multiple values, multiple with the same value, list all of them. This is not a perfect solution, because now this is the control is the user rather than with the system. Now, if you want to take control, fix the problem. But if you want to maybe give more control to the user, you can allow the user to do it. So in this case, now you can see it actually figured out, okay, it's not just MS Dhoni. There are a lot more players with the same price tag. And if you look at the SQL query now it generated, it would be different. Let's come down. Yeah. So what it does, it did. Okay, so it actually created a inner query, a sub query. So it said player price is equal to select max price. Okay, so it created a different query for you just basis that instruction.
Because there are other players as well, right?
Correct. So now that's SQL for you. Now, usually in SQL, right? if you say order by something and limit 1, each database will actually give you, depending on what database you're using. If it's a Postgres, if it's a Oracle, it will choose some row out of all those ones and pick the first one, right? Because we added a limit 1, if you remember.
But order
Order by the player price. Did you? Okay, I'll go back there.
oh yeah, got it.
Was it? Yeah. It said order by the player price because what was the question? The most expensive player, right? So that's why it did by order by a player price. Okay, but as we had a limit 1, it just chose MS only. But now, which came at the top, that's completely on the database. Okay, let's ask another question. Who was the best bowler? Let's see what the answer is. Okay, now look at the response. It's very interesting. The context provided mentions Faf du Plessis as the best bowler, but he's known as a batsman, not a bowler. Therefore, I don't know the best bowler in IPL histories. Now let's go to the SQL query that was generated. So what it says, select player name, sum of total wickets, and what order by the total wickets. Okay, descending. So the player who has the most wickets, he's the best player. I think that's quite a good logic that LLM assume, right? It's not doing anything wrong. But I said factually data is incorrect in this database. If people who are knows or follows cricket quite well, they know Faf du Plessis is actually not a bowler. He's a batsman. Now LLM knows this from its training. Now I have not given this information anywhere in my application, okay, or in my database. This is purely from its training that it knows that Faf du Plessis is a batsman, and it chose to give this response smartly that hey, he ideally is not a batsman. That's not, at least not what I know of. But this was the answer that I got from the system. But I don't feel this is correct. So it gave a response. It did not like completely refrain from giving a response, but it also made sure it makes the user aware of things. But again, if I ask this question again, maybe it might not give this exact response. Okay, it might not say or state that fact. So the response varies a bit. This might be a good thing, this might be a bad thing. Because now it gave some information, maybe what you are not even expecting it to give. In this case, it was a good thing. But maybe in another case, it might expose some information that you never wanted to give the user. So that might be a bad thing. So that's how you ground your LLM and how you restrict your LLM. This is where maybe you might have to add something that's known as guardrails. Again, I won't go into those things. You can look at it later, but this is where you'll have to ground or restrict the LLM. Let's do one final thing. I'll skip these things. All these things are fine. Okay, actually, let's do two more things. I'm asking who was the best all-rounder in IPL? Again, definitely it is going to choose the same tool, right? Okay, the response was what? Mitchell Santner. Now, how did the LLM decide who the all-rounder is, best all-rounder is? And what is the logic? It said, okay, there was a role column in the table. It figured out that had a all-rounder kind of value. So it had that condition. And it said order by total runs. But is this correct? When we say all-rounder, it is not just total runs, right? It ideally should also be basis the bowling figures. So LLM assumed something. I won't say it's completely wrong, but it's partially wrong and partially right. So this is where you come in. You add things to the prompt because you know the business, right? Now, what is the business here? Cricket. What is a use case? All-rounder. maybe LLM is not understanding everything. So you have to ground the LLM here, saying that if this is something, you have to consider these things when you give an answer. This is again two ways to again solve the problem. Either fix the prompt or give the control to the user. Depends on what you want to achieve. Let's jump into something more advanced. And mostly this might be the final part to it. What is the question? Get all the latest matches and using the data available, create a new table in the database. If you have figured, we are actually targeting a question for both the tools. We have said, get the latest matches, which was actually from the API. And we said, after getting the matches, create a new table. Now let's see what it did. It says latest cricket matches, again, similar information. And later it said to create new table in database, you need to include details like whatever, and whatever. Okay. Now let me actually show you the database. Actually, I did not show you this before. Yeah, so these are all the tables that it had. Okay. If it had created a table, there would have been new table here. It's not here. It did not create a table for you. Okay. Reason being, if you remember the agent that I showed you, again, the name itself says it was a simple agent. It does not have the capability right now to do two things at once. And you, as you can see, this actually is quite a complex thing. Because first, it has to get the matches. Basis the output that you got, it has to observe, okay, and now I got the answer. Now I have to somehow create a table. That means now I have to create a SQL query, that is a create SQL query, basis that output it got, and then execute that query. So it's quite a complex task because the sequence is important. If it calls the SQL query first, doesn't work. The sequence is important. So the simple agent that we have, as you can see, we don't have a prompt, right? There was zero prompt to it. Now we might have to give more capability to an agent which can do this. So let's do that. We have one more agent defined actually here in the system. Towards the end, I'll actually tell you what this is so that you have some idea about this from a LangGraph standpoint, because we said this is LangGraph, right? So I'll give you an idea about that towards the end. But let's first understand this more conceptually. Okay, where is this? Create relevant tables. Okay, this is actually not it. This is the SQL one. We have a coordinator one. A workflow to it. So we have a simple agent. I'm going to say I don't want this anymore. Again, I'll come to this in terms of code and what I'm doing here. Let me stop the application. Okay, the application is up. Okay, so these are tables we have. Let me copy this again and let me execute it. Let's see what it does this time. Okay, it's doing something. It's still processing. It definitely made the API call. Okay, did it respond? Not yet. Still doing something. Now you even see, right? Now the earlier questions were responded quite well, quite fast, because that was quite a simple task it had to do. Now it has to do a bit more complex thing. That's why it's taking some time. Let's go. Okay, it's still doing. Okay, finally it's done. Let's see what the response is. Or it's still doing. Oh, it's still doing. We'll come to this part. There's actually a problem. Okay, so what's the final response? A new table name, latest cricket matches, has been created successfully containing the latest match data. Okay, so it at least said that. Let's validate. Okay, so we actually have a table. and we actually have relevant columns and relevant data. And if you remember from the API's response, these were the responses that we had from the API. So what it actually did was it actually called the API, got the responses. Basis the responses, it figured out what the column should be in the first place. So it figured out the column names. Then once the table was created, it figured out data is, and then it created an insert script. So you can see it was not one task or two tasks, it was actually three tasks. API, create the table data. So two calls of the same kind, which was the SQL tool, was called twice. That's why it took some more time to execute everything. Now, how did this happen this time? What is a complex agent? Let's talk about that. Okay, I think I have 5 minutes. Let me go to the SQL. Where is it? Oh, I think I have hard-coded that in here. No, not even hard-coded. I actually have imported this from somewhere because this is a standard prompt that usually works out. This is one of the strategies that we talked about. So when we said that, from a planning standpoint, we can have a lot of strategies. This is something known as a react strategy, okay? Reasoning and acting. And if you look at the prompt, it has a very specific strategy to it. What it says is, again, here also you are giving the tools, very similar to the simple agent. But on top of it, you are giving it a process in terms of how to think about this particular task in hand. It says, you will have a user question. First, what you have to do is think about it. You always have to think about what to do. So you're explicitly saying, don't directly jump to an action. First, think about it. Take some time. Then decide on the action. And what should be the action? The action should be one of those tools. Action should not be something random. It should be out of those tools that you are given. What are the action inputs? So for each action or for each tool, there would be some set of parameters you have defined, right? Declare or give that back as the input. Once that is done, once the action is executed, that is, once the tool is executed, observe it. So you're explicitly saying, observe it. Don't take the next step. First, observe it. And then if you want, you can repeat this loop n number of times. And that is what actually happened in our complex agent. Because it first figured out, okay, the question is, it said, get me the latest matches. Okay. So it said, I have to call the API. As soon as it got the output, it observed that, okay, my task was not just to get the data, I also have to create the table. So it went back. It again thought, okay, now what do I need to do? Okay, I need to create a table. And what do I need to do for that? Call the generate SQL tool. It went back, observed it. It saw, okay, no, that was not my task. I still have to insert the data. It went back. So it actually is following a set process that you have defined. Okay, so just by adding this much block of prompt, right? The simple agent was literally converted into a complex agent, which could actually do a lot more things. And the system is now a lot more dynamic. There are other parts to it. Agent Scratchpad, maybe we'll come to that later if required. Let's see. So this was a complex agent. Again, from a code perspective, this is very short, nothing beyond a few lines of code. Here, actually, we are leveraging something that LangChain is giving. There's something known as a create react agent, which LangChain has out of the box. It does something for you. Again, you can implement this on your own as well. You don't have to actually depend on LangChain. You can replicate this because if you use this, right, you are giving away a lot more control to LangChain. You might not be able to completely have the flow as you expect it to be. So maybe you can implement this on your own as well.
Is it like similar to that prompt engineering part, right? React and chain of thoughts. Right?
Correct. So this is the React one. The chain of thought is a different way of prompting. All of those things are prompting techniques that you can apply to get the best out of our LLM. Finally, I know we talked about, or we said this about LangGraph. I'll just give you 2 hints about it. So when we talk about LangGraph, right, there's just 2 concepts to it. Okay, one is when you talk about our application, right, you obviously can write code hey, do this, do this, do this. You can always do that, not a problem. But it would become a lot difficult to manage things. Rather, when we saw these graphs, right, this actually is getting generated using LangGraph. So what we are doing is we are breaking down the system into multiple components. We are saying we have a component which is get relevant nodes, get relevant tables. We have a component which is this. We have a component which is this. We already saw these components, right? These are different files or classes in itself. We are saying, although these components are different, we want to combine this in a particular fashion. That is, this is the sequence in which we want to combine it or call it. And to do that, we have defined a workflow. What are we saying? Again, when we talk about a graph, we know that, right? There are 2 things to a graph. One is the nodes. Second is the edges between those nodes. So first, we define the nodes. Then we define the edges. So if I again open the SQL one, maybe that will make more sense, right? SQL workflow. Okay. So we are defining the nodes, get relevant tables, generate SQL query, validate SQL query. And then we say what the entry point is. That is, what is the starting point of that graph? We say this is the get relevant tables is the starting point. Once you call or execute the get relevant tables completely, go to the next node, which is retrieving the database schema. Once that is done, go to the next node. So you are literally defining the flow. You can also define conditional edges. We are saying if the query failed, the execute query failed, instead of ending, you can actually go to the loop. We said, right, there is a loop. So if the query execution failed, we are saying it will go to the fixed loop. So you can now actually have dynamic flows in your graph. And that's why you saw what kind of graph, wherein at the end, instead of always going to the end, it can conditionally even go to this flow. So what's the advantage of having a LangGraph kind of thing? You can actually break down the system into n number of components, small components, which are specific to very small tasks. In addition to that, you can define the flow very dynamically. Now, if you saw one thing, when I changed a simple agent to a complex agent, from a code perspective, all that I did was I went to this flow. I removed the simple agent. I simply introduced a complex agent node, and I changed the edge. So you can see now the system is very plug and play kind of thing. I can have a capability. I can plug this in. So tomorrow, let's say if I have another node that actually, let's say, let me come here. Okay. Let's say I want to introduce a node here. I can simply define a node. I can go to the workflow, SQL workflow. I will define a node here. And I'll change the edge. So let's say if it was in between this, what I would simply do is I'll add here. I would say instead of directly going to this, there's a new node now, X, that would come here. And now that would call the retrieve database schema. So you can literally plug and play a lot. You can remove components, you can add components. That's how LangGraph will help you in terms of your application architecture and everything. So LangGraph just helps you from the engineering standpoint, I would say, and how you can build a more adaptable, more plug and play kind of architecture for your application. Okay, so that's in terms of LangGraph. And from a conceptual point, again, LLMs is obviously driving everything. It decides for you basis the tool descriptions, the tool names. It decides basis the user question and a database schema, what the SQL query is, what the API request it needs to create, and it executes for you. But as you can see, overall, it's a very dynamic system now that you have built. You're not even defining how to create a SQL query. That is done dynamically, based on the user question and the capability that you have defined. Any questions in terms of the code? Anything that you want to see more, that you could not understand? Okay, hey, how did that happen? Yeah. Yeah. So I think I'll actually jump to the PPT to answer the question. Okay, so let's go to the challenges part of it. Now, one of the most biggest problem that you will face, hey, from an accuracy standpoint, it might work well. Maybe at least from a demo that I gave, I think things went well. Maybe I'll run this maybe another 5 or 10 times. You might see some differences or some execution flows that it took. It did not things to like it did not do things as it was expected to do. For example, let's say I would have said it to create a table. Maybe it created a table, but it would not have inserted the data at in some case. So accuracy is one thing, but getting that consistently, that's a huge challenge. And to achieve that well, you have to take care of multiple things. You'll have to fine tune the prompt a lot. Basis your experiments that you do, you'll have to see, okay, this is where things are going wrong. You'll have to fine tune the prompt. Take control back. Like maybe I'll come back to the solution a bit later. But consistent accuracy is a big challenge. When we talk about cost, we are making LLM calls, right? At the beginning, you might see, okay, the cost is fine, everything is good, because for each 1,000 or million tokens, it might take what point, let's say 10 cents or $1 or something, it's fine. But as soon as the system start to scale, there's from 100 users to 1,000 users or 1 lakh users, the number of tokens that are getting used will exponentially increase. And when the cost that you are looking at the start, that will also exponentially increase. So that's a huge challenge. Latency. Now in the system you saw, we are not making one LLM call. We are making n number of LLM calls. For example, we did an LLM call to decide the tool. We made an LLM call to generate the SQL query. We made one to generate the API request. So the more the number of LLM calls, because for each LLM to respond back, it takes some time. So latency of your overall application, that goes beyond, because I think we saw at the end, right? It took some significant amount of time to execute that task. Whereas the first task that we gave, it was quite quick. So latency is a problem from a user standpoint. Debugging is a pain because you don't know what the LLM did at that point in time. It definitely gave an output. Now, you don't know how to fix that because you don't know what logic it assumed to give a response. So debugging is a problem. Testing is a bigger problem. I would say that's the biggest problem out of everything. Because this is a dynamic system. How do you test a dynamic system? Because LLM can respond with anything, right? Testing a deterministic system is quite straightforward. You know what you can expect as an output. So you can literally say, this is the expected output, compare it with this, you are good. But when we talk about a dynamic system like an LLM or non-deterministic thing, you don't know how to test. It's a big challenge. So from a learning standpoint and how to fix those challenges, let's go through a few things. From prompting standpoint, right? Ideally, you can write anything in a prompt. Whatever you feel like, add in statements, add in English, everything is good. But ideally, use proven strategies like a React one or a chain of thought things, because that are proven things wherein the LLM responds back or things in a very well structured manner, and accuracy would be good. So always try to follow a well proven structured prompting technique. Always give out responses in a structured manner. As I said, if you don't ask it to give the response in a very structured way, it will give you anything and it might not work for you. Use appropriate LLM models for different tasks, because an SQL generation versus a tool calling, these are completely different capabilities for or capabilities that you're looking at. Some LLMs might do a good job with SQL generation, but it might equally do bad with a tool calling kind of thing. So choose appropriate models for each task. Don't use the same model across.
I have a question now. For we are using LangGraph. Is it possible to use OpenAI for natural language thing?
Yep.
And then once we are calling the tool, we will use different model which is capable of doing SQL only.
Yes. So we already have done this in this application. And that's not something related to LangGraph. It's purely engineering part of it. Here, if you see now, again, this I want to keep it simple. So you can see in this component, generate SQL query, the LLM that I defined as GPT-4o mini. Okay, and this is the LLM that is being used to generate the SQL query. But if I go to a complex agent, I'm using an LLM. Where is that LLM? Yeah. Okay, here again, I've defined a 4o mini, but you can literally actually say use GPT-4o instead of 4o mini. So because I have broken down my application into components, each component can leverage a different LLM. Doesn't matter. So you can use any LLM for any task. You are not restricted by it. So again, it's an engineering problem, not a LangGraph or a LLM problem.
Yeah, because like why I'm thinking about this is we are using LangGraph, right? And each state is actually connected.
Correct.
So therefore, if I separate that out from the graph point of view, break the context. Therefore, I'm asking.
But again, in this case, it's not breaking anything, right? Because this component's task is to maybe do a tool call and respond back. The other tool does not even know what this component is doing. It does not even need to know, right?
True.
So doesn't matter what model this is being used here, the other component is not impacted.
Yeah, it's similar to API call. It's just exchanging the data.
Yes, exactly. It just matters what the input and the output is. That's it.
Does it support self-hosted?
Yes, it does. You can have self-hosted models. When you define the LLM, you just have to give the endpoint to that self-hosted server. That's it. Okay, yeah. Finally, as you see, again, we broken down the application into n number of components, right? You are saying if you break down the application into a lot of components, that's the best in terms of accuracy, like single responsibility principle in terms of the normal code that we talk about. But that's a trade-off, okay, here. It will give you high accuracy, but the latency would be higher as well. So there's a trade-off. You have to choose a sweet spot. Although we are talking about LLMs, the more you can take the control back, the better. If you can do something programmatically, please do that. Don't depend on LLM, because that would be not just accurate, it would also be faster. It would be cheaper. Okay, so anything you can do programmatically, do that. Things like dynamic decision making, definitely you can't do that, right? Give that to the LLM, that's fine. And when we talk about debugging, that was one of the problems, right? How do you debug? This is one way you can do. So for each component, you can also ask the LLM to generate a thought process. So in the response, you said generate SQL query, give a Boolean. You can also say generate a thought process. So it will actually give you detailed steps in terms of how it came to a conclusion that maybe this is how to generate SQL query. And basis, like looking at that thought process, you can see what the problems were and how you can fix maybe the prompt to fix that problem. So this is not a traditional way of debugging that, definitely, but this is one way you can debug. That is to understand what thought process the LLM took, get that in the output, and then fix it. Again, that's a trade-off. More things you add in the response, the slower the response would be. So maybe once you fix these issues, right, in the production, you can remove these thought processes.
I'm doing the different things. So we are actually capturing all the thinking part and tagging whether it's correct or not. Creating a model on top of that.
Yeah, you can do n number of things. Also, there's again, research says multiple things. If you actually add a thought process, LLM's accuracy might increase. There are some research that right now says LLM capabilities has reached that point that now it's not required anymore. But again, that's debatable. You'll have to literally see. Finally, from a testing standpoint, if you end up saying that I'll test this application manually, you will never go to production, because you can see what is driving this application. Prompts are driving the application. You make a change in one prompt, you don't know what will break in a different part of the application. You will never know. It's not a traditional application. If you end up doing like traditional testing or manual testing, things are going to break by a single small change, and you are not going to do a regression end to end, right? Because your application might have thousands or lakhs of use cases. You're not going to run a regression every time manually. You have to automate things. Now, how to automate things from an LLM standpoint? I said that's a non-deterministic task. That's a whole different challenge altogether. Maybe we'll have a different dev day for that, because that's not a 5-minute thing. That's not even a 1 hour thing. It can actually go into days if you want. So we might have a different dev day altogether, just focusing on that point, how to test a LLM kind of application and make it automated. Okay. But again, don't do it manually. There are a number of tools out there. There are tools which OpenAI gives. There are tools specifically for task, actually, for example, for SQL generation, right? There is a model known as SQL Coder, which is fine-tuned on a Llama, which works well on SQL generation. But what they have done is they also created a evaluation tool to check how the SQL or how good the SQLs were generated. So there are a number of third parties. I think there is something known as not Brain Bench. There's something known as Brain something else. But again, in the industry, there are a number of tools out there that you can leverage and make your testing automated. But again, it might work for you, it might not work for you, depends on your use case. Okay, finally, again, nothing here. There are some resources in terms of the code that we implemented, right? The application, the strategies that we used, all those are present in these resources. You can go through this offline, because definitely you might not have got all the details of the application. You can go through these links if required. Finally, question and like any Q&A, anything that's not clear, we can go through that. Yes. So if you remember the first component that we had, to get relevant tables. Right now, I was passing every table or the complete schema to the user. One solution that I gave, if you remember, was have a vector DB in place. For each table that you have the metadata. Basis the user question, vector database will give you the most relevant tables. Now only provide the schema related to the most relevant tables to the LLM. Don't give the complete schema. That's how you restrict the prompt length or reduce the prompt length. Yes. So now, with respect to that, again, there are again a lot of strategies. One way is, when you call an LLM, you attach, so as part of the prompt, right? You attach even the previous question and the answers in that prompt itself as a dynamic component. And at the end, you have the current question. So what the LLM does is actually looks at the previous conversation. It figures out if anything needs to be changed in the current question, and it will create the question in such a manner that the old context is taken care of. This is one way. You can actually have history attached to all the components that we have here. For example, in the SQL generation, you can have the previous SQLs that were generated in the history. Sorry? Yes, SQL. Again, it depends on how you want to solve the problem and what your use case is. But ideally speaking, exactly. So you'll have to restrict it in some way. Maybe simplest solution is limit the last n number of, give it the last number of n number of questions or the conversations. Or there are strategies like summarize everything that you have till this point in time and give the summary to it. It depends on what you want to solve and how well you want to solve, because each solution has its trade-off. So yes, exactly. So that's a third solution. So you can get maybe the most relevant one, like the most relevant conversational parts from the complete history, and just pass those. That's a different problem, a different solution. Yep. So the answer is actually very simple. Let's go back to the traditional application. How do you choose a framework? How do you choose a framework? How do you say, let's say if it's a Java, how do you say, when do you say I want to use a Spring versus when I do not want to use a Spring? Or when do I want to use a Hibernate versus I do not want to use Hibernate? The question or the approach you follow is exactly same. One way is ask a question, how much control do you need? For example, a framework like a Crew AI versus a framework like a LangGraph. Crew AI would actually allow you to build things quite faster. You can build things that are way dynamic. But when it comes to the amount of control that you have, right, it's very limited in Crew AI. But in terms of LangGraph, for example, you have a lot more control because as you can see, what LangGraph did for you was not, from a LLM standpoint, it did not do much. Rather, it helped you in terms of the architecture of the overall application, how it can be broken down, how it can be managed. AutoGen, again, that's a good application. I would say better, definitely better than Crew AI because it gives you a lot more control. But when you compare it with LangGraph, again, I would say the use case or the need for using a LangGraph versus AutoGen is completely different. Okay, because LangGraph, again, it's not helping you in terms of orchestrating things very dynamically. If you look like at an AutoGen, what it does is, do you remember the first example that I gave? Like you had a supervisor, you have a content creator, you have a content extractor. Now the supervisor is doing everything, like it decides which agent to go to, when to go to, and how to go to. AutoGen does this quite well out of the box. However, if you want to do similar functionality in LangGraph, you actually have to do a lot more in terms of implementation, in terms of code. So obviously you have a lot more control, but from an implementation standpoint, you have to do a lot more. Not necessarily. No. I won't say that. Again, it depends on the use case and how fast or how accurate you want the system to be. So again, I don't think we'll have a concrete answer for this question because again, go back to the traditional application. You can never say every time use Hibernate. That won't be the right answer, right? There might be a number of situations where you should not use a Hibernate or you should not use a Spring because it's not required at all in first place. It depends on the use case.
Because now most of the APIs support structured outputs needed.
Right.
Then to see one using a framework versus pure Python.
Again, if you want 100% control, I would say use pure Python. No one's stopping you. Like you can literally do anything. Now you can achieve anything. Why are frameworks there in the first place? To help something, right? To make things faster, to make things done in a most standard way. Because if you end up implementing things, you might not know the best practices, right? I'm not saying frameworks are the best, like they are following the best practice. It might happen they are actually doing bad, like things very badly. But hopefully the framework that we choose are doing things much more better than what we would have done. So again, if you want complete control, any day I would say don't use a framework. That's the best way. Like that's the best you can do. You can do literally anything. Yep. Mm-hmm.
Better than in the single agent with multiple, right?
Yep.
So how does a company like Mars is operating in, like they are using a single agent and providing like multiple possibilities?
To be frank, I don't know what they are doing. I don't know what their implementation is. And I'm not sure if they are using a single agent to do everything.
Mars is like promoting like it's single agent and
Externally, maybe from a user standpoint, yes, it's a single agent. Internally, how it's processing everything, there might be multiple agents underneath. Again, not sure what the implementation is, not sure how it's being done.
and also there's a lot of buzz about MCPs and
Hmm. Oh, what do you mean by MCV? I don't know. Okay, sorry, I don't have much context about it. Any other questions? Sorry?
Started 5:20, right? Students ask, yeah, so much patiently people are there. Nice, we want to know the feedback. We can answer, but we can share this information. Reach later on remotely. Okay, feel free to reach. Maybe the way they get reach, that's great. Your idea for feel free to. Want to know your feedback, actually, what you like the session. Your presence tells a lot. Want to learn some curiosity is why maybe you're here. But take some feedback on that. Was that very good? Would like to share, right? Keep to share feedback. Yeah, you can give a feedback on this QR code. The QR code is placed across the Google at many places. So, yes. And thanks, Steven, for this wonderful talk. So there is another event by update next month.
Oh, sorry, about that one, right?
Uh-huh.
Think, yeah.
So, yeah. Sorry, before that, let them say something. Yeah, like why they also write feedback. Takes dividends. It answer your question or no? Yes.
Hey, please do give the feedback because that's valuable to us. We can improve a lot.
Raise your hand to a particular agentic AI development. Bring your student. Expected to ask a question, right? AI is good. That's just interesting. Looking out to create an agent for sales people. Basically, my company works in intelligence. Creating agents for different departments. Retailers.
Okay.
The major challenge is basically like creating boundaries. The question that can be asked.
Yep.
We have a place because any company, retailer knows the company data.
Yes. So that's something maybe I just put in a keyword, guardrails.